So what is confidence intervals and why is it important in our calculations? So normally when we do any experiment, we can never find the true population mean and the true standard deviation because we usually run a limited number of experiments. So we only have the sample mean and the sample standard deviation. The confidence interval from the name allow us to say with a certain level of confidence that actually the range of measurement we found, including the mean and the standard deviation, will include the true mean of the sample. So the equation to calculate the confidence interval here, this is the confidence interval, equals the sample mean plus or minus t times s divided by the square root of n. So t is basically the t value that we get from the t table, and it defines which level of confidence we are using. So if we are talking about the 95% confidence level, then we will look at the t value at 95 confidence interval at a certain degree of freedom depending on the number of measurement. Remember that the degree of freedom equals number of measurement minus 1. So degree of freedom always equals n minus 1 when we calculate the confidence interval. And then S is the standard deviation that we calculated from our measurement. So it's our sample standard deviation. And N is the number of measurement. So let's have a look at an example in order to understand how can we calculate the confidence interval and what exactly does it mean. So if there is an experiment where we try to calculate the carbohydrate content of glycoproteins, and we ran here 1, 2, 3, 4, 5 measurements, and we found these are the different values or the different concentration or the different carbohydrate content of a glycoprotein. And now we want to find the 50% and 90% confidence intervals for the carbohydrate content. What we need to do first, we need to calculate the mean and the standard deviation of our sample measurements. So this is the sample mean and the sample standard deviation. So if you do calculate the mean, it will be 12.5 and the standard deviation is 0.4. So now I calculated the mean and I calculated the standard deviation. What I need to find now is the t from the table, from the table of the at the different the t table at the different confidence levels. So when we try to calculate the 50% confidence interval, we will apply the 50% confidence interval. We will apply the equation, which is it equals mean plus or minus t times s divided by the square root of n. We said that we have 5 measurements, so n here equals 5. And remember, degree of freedom equals n minus 1, so it's 4. Let's have a look at the table. So now we need to look at the 50% to find the t value. So a degree of freedom of 4 and 50% confidence interval. So you have a look at this. So it's equals to 0.741. So this is the t I'm going to use in my equation now. So the 50% confidence interval will equal the mean, which is 12.5 plus or minus t, which is 0.7. We found that it was 0.741 times s, which is 0.4 divided by the square root of 5. And if you calculate this, you will find it equals 12.5 plus or minus 0.1 weight%. That means that our confidence interval, 50% confidence interval, is between 12.4 to 12.6. So that means that I am 50% confident that the true population mean will be in this range. So this is the meaning of 50% confidence interval. That means I can say that I am 50% confident. I'm not 100% confident. I'm just 50% confident that the true mean value will be in this range between 12.4 and 12.6. So let's calculate then the 90% confidence interval. All the values will be the same except for t, so it's 12.5 plus or minus. Let's have a look at the t. Now we look at, again, degree of freedom is 4, but it's 90%, so this one is 2.132. So I will put this in my equation, 2.132 times 0.4 divided by the square root of 5. My answer will be 12.5 plus or minus 0.3. That means now my interval is 12.2 up to 12.8. That means that I am 90% confidence, or there is 90% chance that the true value or the true mean will be within this range, 12.2 and 12.8. That means there is still 10% chance that the true value will be outside this range, but I am 90% confident now that it's within this range. If I want to calculate it for 95 or 99.9, you will find that this range will again increase. So I will get to a confidence level that I say that 99.9% I'm confident that the true value or the true mean will be within this range. This is what's meant by the confidence interval and how we calculate it. The meaning of the confidence interval, let's have a look at this figure. Try to understand more what is meant by the confidence interval. So this is an experiment. We ran an experiment like 100 times, okay? And we calculated the 50% confidence of interval for all our experiments. So if we repeat an experiment an infinite number of times, okay, then this is the true mean of our calculation, which is 10,000. So now we only ran this experiment 100 times. So 50%, we would expect now that 50% of the error bars, the one here we see, so every one of these values is the mean and then the error bar for each time we run our experiment. So 50% of the error bar would include the true population of the mean of 10,000. Actually, when we ran this 100 times, as you see, 100 times the experiment, we would find that 45% of the error bar actually go through the actual true mean. So 50%, around 50%, it wasn't 50% exactly, it was 45% of the error bars will pass through the horizontal line at 10,000. If we do the same, but we calculated the 95% interval, so the error bar here is for the 95 or the 90%. Now we're talking about 90% confidence interval. So the error bar here reflects the 90% confidence interval. And we run the same experiment 100 times. And we know that the true value or the true mean is the 10,000. You will see that 89 of the 100 error bars will actually cross the horizontal line of the true mean. This is what's meant by the confidence interval. So 90%, I'm 90% confident. I'm 90% confident that that the error bar or my value, including the error bar, will actually include the true mean of the experiment, or the true mean of the value. So confidence intervals can be used as you have seen in the last two slides. We have been using it as a method of calculating uncertainty or error bars. So previously we did use the standard deviation as a measure of the uncertainty. We can also use the confidence interval, but you have to specify in your answer, or specify in your measurement or in your results which uncertainty did you use, or which uncertainty term did you use. So if you use a standard deviation, you say the error here, or the uncertainty, is by using the standard deviation for n n of measurements. If we use the confidence interval, we have to say that we are using the confidence intervals at which confidence level. So you have to specify exactly which confidence level you have been calculating your confidence interval. So the uncertainty, we are don't just we are not just use we don't just use the standard deviation. We can also use the confidence